Hello students, welcome to today's lecture. In today's lecture, we are going to solve JEE previous year questions on thermal properties of matter. This is disclaimer. Learning objectives. By the end of this lecture, you will able to solve questions on thermal properties of matter by applying concepts of the temperature and heat, measurement of temperature, calorimetry, specific heat capacity, and thermal expansion using proper reasoning and calculation. All right. So question is, a copper ball of mass 100 gram is at a temperature T. It is dropped in a copper calorimeter of mass 100 gram filled with 170 gram of water at room temperature. Subsequently, the temperature of the system is found to be 75 degrees Celsius. T is given by what? And the room temperature is 30 degrees Celsius and the specific heat of copper is equal to 0.1. So here you have to find out the value of T. Alright. The given options, option is 1250 degrees Celsius, option B 825 degrees Celsius, option C 800 degrees Celsius and option D 885 degrees Celsius. So which option is correct? Please solve this question. You have some time. Let's see the solution of this question. So, given terms, first mass of the copper ball is equal to 100 gram. Mass of the calorimeter is 100 gram. Mass of the water 170 gram. Final temperature of the system TF is equal to 75 degrees Celsius. And initial temperature or we can say room temperature, that is equal to T naught equal to 30 degrees Celsius. Specific heat of copper is equal to 0.1 calorie per gram degree Celsius. Specific heat of water 1 calorie per gram degree Celsius. Alright, so using these given terms, we will solve the value of T. So here we have to find out the value of T. So before finding, we will calculate some important phenomena, just like a heat lost by the copper ball is Q loss is equal to M copper S copper into T minus TF. Alright, so just put the value of M, S and T you will be get Q loss. It means heat loss by the copper ball is equal to 100 into 0.1 into T minus 75. So 100 into 0.1, it will be 10 into T minus 75. Alright. So this is the heat lost by the copper ball. Now similarly, we will calculate heat gained by the copper calorimeter is Q is equal to M S Tf minus T naught. So put the values. So Q, or we can say heat gained by the copper calorimeter is equal to 100 into 0.1 into 75 minus 30. So just multiplied, you will be get 450 calorie. Similarly, we will calculate for water. Now heat gained by the water is Q is equal to MW SW Tf minus T naught. So put the values, that is 170 into 1 into 75 minus 30. So solving this, you will be get heat gained by the copper, heat gained by the water is 7650 calorie. Now using these terms here, we will calculate the value of T by using the principle of calorimetry. So heat lost is equal to heat gain by the calorimetry plus heat gained by the water. Just put the values. So it will be 10 into T minus 75 is equal to 450 calorie plus 7650 calorie, right? So 10 into T minus 75 equal to 8100. So solving this, you will be get T minus 75 equal to 810. Alright. So solving for T. So T minus 75 is equal to 810. So T equal to 810 plus 75 degrees Celsius. So when we adding, it will be 885 degrees Celsius. It means the correct option is D, that is 885 degrees Celsius. Alright. Second question. A non-isotropic solid metal cube has coefficients of linear expansion as 5 into 10 raised to the power minus 5 per degree Celsius along x-axis and 5 into 10 raised to the power minus 6 per degree Celsius along y-axis and z-axis. If the coefficient of volume expansion of the solid is C into 10 raised to the power minus 6 per degree Celsius, then the value of C is what? So here the coefficient of volume expansion is given in the form of C and you have to find out the value of C, capital C. Alright, please solve this question, you have some time. After that we will provide the solution of this question. Let's see the solution of this question. So, are the given terms. First, the coefficient of linear expansion along x-axis is alpha x is equal to 5 into 10 raised to the power minus 5 per degree Celsius. And coefficient of linear expansion along y-axis and z-axis is alpha y equal to alpha z. It means both are same, that is 5 into 10 raised to the power minus 6 per degree Celsius. Coefficient of volume expansion, that is gamma equal to c into 10 raised to the power minus 6 per degree Celsius. Alright. So here we have to find out the value of c. Now, coefficient of volume expansion is related to coefficient of linear expansion. So, gamma equal to alpha x plus alpha y plus alpha z. By substituting the given values in the above expression, it will be 5 into 10 raised to the power minus 5 plus 5 into 10 raised to the power minus 6 plus 5 into 10 raised to the power minus 6. Now here, look at here, the power, or we can say 10 raised to the power minus 5, 10 raised to the power minus 6 and 10 raised to the power minus 6. So the powers are different. So first convert 5 into 10 raised to the power 10 raised to the power minus 5 to the same power of 10 as a 5 into 10 raised to the power minus 6. So it will be 5 into 10 raised to the power minus 5 is equal to 50 into 10 raised to the power minus 6. Alright. Now substituting the values. So, and add all the values and solve for volume expansion. So, gamma equal to 50 into 10 raised to the power minus 6 plus 5 into 10 raised to the power minus 6 plus 5 into 10 raised to the power minus 6. So, solving this, you will be get 50 into 10 raised to the power minus 6 plus 5 plus 5 into 10 raised to the power minus 6. Alright. Now, further calculation, it will be 50 into 10 raised to the power minus 6 plus 5 plus 5, 10 into 10 raised to the power minus 6. Now here the power of 10 is same in both cases. So it will be 60 into 10 raised to the power minus 6 per degree Celsius. Alright. Now, coefficient of volume expansion is given in the form C into 10 raised to the power minus 6 per degree Celsius. Alright. So for our calculation, from our calculation, gamma equal to 60 into 10 raised to the power minus 6. So when we comparing both expressions, so C into 10 raised to the power minus 6 is equal to 60 into 10 raised to the power minus 6. So when we comparing, C is equal to 60. Yes or no? So we can say the value of C is equal to 60. Alright. Each side of a box made of metal sheet in cubic shape is A. At room temperature T, the coefficient of linear expansion of the metal sheet is alpha. The metal sheet is heated uniformly by a small temperature delta T, so that its new temperature is T plus delta T. It means after heating the temperature is increasing, that is T plus delta T. Calculate the increase in the volume of the metal box. It means here you have to find out the increase in the volume of the metal box. So given options, option A 3a cube alpha into delta T, option B 4a cube alpha into delta T, option C 3 pi a cube alpha into delta T, and option D 4 by 3 pi a cube into alpha into delta T. So which option is correct? Alright, please solve this question, you have some time. After that we will provide the solution of this question. Let's see the solution of this question. So, it is given that box is a cube with each side of length A at room temperature T. Volume V of the cube is cube of side. So cube of side. So here side is L A. So A cube is the volume. When the temperature of the metal sheet is increased by delta T, in that case, each linear dimensions of the cube will expand. So suppose we have a cube and when we heat it, so their dimension will be increased. Alright. Change in length delta A for each side due to thermal expansion is delta A is equal to A into alpha into delta T. Here alpha is the coefficient of linear expansion. Now new length of each side after heating is A prime is equal to A plus delta A. So here A is the old length or and delta A is the change in length. So new length become A plus delta A. New length of each side is A plus delta A. So it will be A plus A into alpha into delta T. So we know the value of A prime is equal to A into 1 plus alpha into delta T. Alright. New volume of the cube after heating is V prime equal to cube of A prime, because A prime is the new side length of the cube after heating. So V prime equal to cube of side, that is A into 1 plus alpha into delta T whole cube. So it will be V prime equal to A cube into 1 plus alpha into delta T whole cube. Alright. Now, since delta T is small, so we can say alpha into delta T will also be small. And for small x, we can use the binomial expansion, because here we saying that delta T is a very small. So the binomial expansion 1 plus x whole power n is approximately equal to 1 plus nx for small x. But here x is equal to alpha into delta T and n equal to 3. So it become 1 plus alpha into delta T whole power 3 is approximately equal to 1 plus 3 times of alpha into delta T from the binomial expansion. So as we have the new volume is equal to A cube into 1 plus alpha into delta T whole cube. So it will be V prime is equal to A cube 1 plus 3 alpha delta T. So solving this, you will be get A cube plus 3 into A cube alpha into delta T. Now increase in volume delta V is final volume minus initial volume. So here final volume means after heating V prime, and before heating the volume is V. So it will be A cube plus 3A cube alpha into delta T minus A cube. So delta V is equal to 3A cube alpha into delta T. Alright, this is the increase in volume. Now, thus the increase in the volume in the metal box is 3A cube alpha into delta T. So in this question we have to find out the increase in the volume, that is we calculated here 3A cube into alpha into delta T. Alright. At what temperature a gold ring of diameter 6.230 centimeter be heated so that it can be fitted on a wooden bangle of diameter 6.24 centimeter. Both the diameters have been measured at room temperature, that is 27 degrees Celsius. Given coefficient of linear thermal expansion of gold, alpha L is equal to 1.4 into 10 raised to the power minus 5 per Kelvin. So here you have to find out the temperature. At what temperature a gold ring is become the diameter 6.230. So given options, option A 125.7 degrees Celsius, option B 91.7 degrees Celsius, option C 425.7 degrees Celsius, and option D 152.7 degrees Celsius. So which option is correct? Please solve this question. You have some time. Let's see the solution of this question. Now, the given terms. So diameter of gold ring is 6.230 centimeter and diameter of wooden bangle is 6.241 centimeter. Initial temperature T naught equal to 27 degrees Celsius. Coefficient of thermal expansion of gold, that is alpha L, is equal to 1.4 into 10 raised to the power minus 5 per Kelvin. Alright. Now, change in diameter needed for the ring to fit over the bangle is change in diameter is equal to diameter of the bangle minus diameter of the ring. So diameter of the bangle, that is 6.241 centimeter minus 6.230 centimeter. So solving this, you will be get delta D is equal to 0.011 centimeter. Alright. So expression for linear thermal expansion is delta D is equal to diameter of ring into alpha L into delta T. So substituting the known values in the above expression, you will be get 0.011 centimeter is equal to 6.230 centimeter into 1.4 into 10 raised to the power minus 5 per Kelvin into delta T. So using this expression, we will find the value of delta T. Now, rearranging the equation to solve for delta T. So it will be 0.011 centimeter divided by 6.230 centimeter into 1.4 into 10 raised to the power minus 5 per Kelvin. So it will be 0.011 divided by 6.230 into 1.4 into 10 raised to the power minus 5. Solving for delta T. So delta T is equal to 0.011 divided by 8.722 into 10 raised to the power minus 5. So it will be 126.0. Alright. Now we can find the final temperature Tf as Tf equal to T naught plus delta T. So Tf equal to 27 degrees Celsius plus 126.0 Kelvin, because we know delta T is equal to 126. So since change of 1 Kelvin, listen carefully, change of 1 Kelvin is equal to a change of 1 degree Celsius. So we can directly add the change in temperature to the initial temperature. Alright. So Tf equal to 153 degree Celsius. So a gold ring should be heated to approximately 153 degrees Celsius to fit over the wooden bangle. Alright. On a temperature scale X, the boiling point of water is 65 degree X and the freezing point is minus 15 degree X. Assume that X scale is linear. The equivalent temperature corresponding to minus 95 degrees X on Fahrenheit scale would be what? So here in this question you have to find out the equivalent temperature in Fahrenheit scale. Alright, will be what? The given options: option A minus 63 degree Fahrenheit, option B minus 112 degree Fahrenheit, option C minus 48 degree Fahrenheit, and option D minus 148 degrees Fahrenheit. So which option is correct? Please solve this question. You have some time. After that we will provide the solution of this question. Alright. Let's see the solution of this question. Given boiling point of water on scale X is 65 degree X and freezing point of water on scale X is minus 15 degree X. Alright. Convert the temperature from scale X to Fahrenheit scale. So here to converting we will use the linear relationship between the scale X and the Fahrenheit scale. So let here Tx be the temperature in scale X and Tf be the temperature in Fahrenheit scale. So the boiling point and freezing points of water in both scales we know. So boiling point 65 degree X and it will be 212 degree Fahrenheit. Similarly, freezing point minus 15 degree X and 32 degree Fahrenheit. You know, in Fahrenheit degree scale temperature, the lower fixed point is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit. So for linear scales, the ratio of temperature differences is constant, and we can write Tx minus freezing point in X scale divided by boiling point X minus freezing point X is equal to Tf minus freezing point F divided by boiling point F minus freezing point F. Alright, so using this concept, we will put all given terms in the relation. So it will be Tx minus minus 15 divided by 65 minus minus 15 is equal to Tf minus 32 divided by 212 minus 32. Alright. So the relation between Tx and Tf is Tx plus 15 divided by 80 is equal to Tf minus 32 divided by 180. So solve for Tf when Tx is equal to minus 95 degree Fahrenheit, minus 95 degree X. So substitute Tx is equal to minus 95 into the equation. So it will be minus 95 plus 15 divided by 80 is equal to Tf minus 32 and divided by 180. Here we just put the all given values in the linear relationship value equation. So solving for Tf, so it will be minus 80 divided by 80 is equal to Tf minus 32 divided by 180. So it will be minus 1 is equal to Tf minus 32 divided by 180. So it will be minus 180 is equal to Tf minus 32. So solving for Tf, Tf is equal to minus 180 plus 32. So it will be minus 180 degree Fahrenheit. Alright. So the equivalent temperature corresponding to minus 95 degree X on the Fahrenheit scale would be minus 148 degree Fahrenheit. Alright. So this is the our correct answer. The D option is correct. The total radiant energy per unit area normal to direction of incidence received at a distance r from the center of a star of radius r whose outer surface radiates as a black body at a temperature T Kelvin is given by what? Where sigma is equal to Stephen's constant. So here you have to find out the Tk. Please solve this question. You have some time. Let's see the solution of this question. So, first, we will calculate the total radiant energy per unit area received at a distance r from the star. Star's outer surface radiates as a black body at a temperature T Kelvin. You know what is black body? A black body is a ideal body that absorb all radiations. All right. According to Stephen Boltzmann law, E is equal to sigma into T raised to the power 4, where sigma is the Stephen's constant and surface area of the star is A is equal to 4 pi r square. R is the radius of the star. So the total power, or we can say total power emitted by the entire star is the product of its radiant emittance and its surface area. So it will be E into area. All right. So total power is L equal to sigma into T raised to the power 4 into 4 pi r square. So L is equal to 4 pi r square sigma into T raised to the power 4. So total power L is the radiated uniformly in all directions from the star. So at a distance r from the center of the star, the power is distributed over an imaginary spherical surface of the radius r. So area of this imaginary spherical surface is 4 pi r square. So total radiant energy per unit area normal to the direction of incidence received at a distance r, here we called flux or intensity, is I equal to L by A. So put the values, it will be 4 pi r square sigma into T raised to the power 4 divided by 4 pi r square. So I equal to r square sigma T raised to the power 4 divided by r square. Alright. Rearranging the terms, you will get I equal to sigma into T raised to the power 4 r into r divided by r whole power 2. So I is the required total radiant energy per unit area received at a distance r from the star. So this is the I. The emissive power of a black body at T equal to 300 Kelvin is 100 watt per meter square. Consider a body B of area A equal to 10 meter square. Coefficient of reflectivity R equal to 0.3 and the coefficient of transmission T equal to 0.5. Its temperature is 300 Kelvin. Then which of the followings are correct? First, the emissive power of B is 20 watt per meter square. The emissive power of B is 200 watt per meter square. And the power emitted by B is 200 watts. And the emissivity of B is 0.2. So this is multiple select question. There is more than one answer is correct. So please solve this question. You have some time. After that, we will provide the solution of this question. Let's see the solution of this question. So, the given terms, emissive power of black body at T equal to 300 Kelvin is 100 watt per meter square. For body B, area is 10 meter square. And coefficient of reflectivity R is equal to 0.3. Coefficient of transmission T equal to 0.5. And temperature 300 Kelvin. For any body, the sum of reflectivity, transmittivity and absorptivity is 1 for any body. So we can write alpha plus R plus T is equal to 1. Alright. So we know alpha plus 0.3 plus 0.5 is equal to 1. Here R and T are given. So solving this, you will be get alpha is equal to 1 minus 0.8. So it will be 0.2. Alright. Now, according to Kirchhoff's law, the thermal radiation for a body in a thermal equilibrium, its emissivity E is equal to its absorptivity, and that is alpha. So we can write E is equal to alpha. So E equal to 0.2. Alright. So coefficient of emissivity of the body B is 0.2. Now, emissive power of a real body, body B is B is equal to E into E. So EBB is the emissive power of black body at the same temperature. So it will be 0.2 into 100 watt per meter square. So you will be get 20 watt per meter square. Alright. So emissive power of a real body is 20 watt per meter square. Alright. Total power emitted by body B is emissive power into area. So emissive power is 20 watt per meter square into area, that is 10 meters square. So power emitted is 200 watt. So total power emitted by the body is 200 watt. Alright. So this is the answers. Thank you for your attention.